I'm gonna now demonstrate how to apply a dynamic loading. First, you should be going to define, and so the dynamic loading comes under the first. You need to go to functions, then go to time history, and let's assume that we there are a lot of different types of time history functions available. So let's go with like the sine one and add new function, and it's giving you for the different time periods and the value. So period is like the what's the time period for one cycle. So this is like about one cycle from here to it goes until here, and number of steps per cycle. So between this to this how many steps are there. So 1 second is divided into 20 parts. So if you see, if you divide 1 second by 20 parts, you get 0.05 as the number. So it's so on up to this, and number of cycles, so this repeats up to 5 cycles. So 1, 2, 3, 4, and then 5. And what is the amplitude? Let's keep this the standard value. So you can see that number of steps is 20 per cycle into 5, so it's 100. Remember that number. We'll give it like uh, example sine load, uh, we, and we can just mention the values of time period equals to 1 second and amplitude equals to 1. Okay, and once we are done with that, we just press OK. So this is we have defined a function, a dynamic function using the time history. Now once we are done with that, uh, then we go there and define the load pattern. In load pattern, let's define this as another load because it doesn't fit any of this. It's not seismic as well. It's just a simple dynamic load. I'll give it sine load, zero self-well multiplier, add new load. Okay. After defining the load pattern, we'll go to load case, and it's showing here linear static. So we should be modifying that. It's no more linear static, it's actually time history. We have defined the function as time history. Now, as you can see here, the number of outputs is 100, and we saw that there were 100 coordinates. So it's fine. And let's go for we can, since it's a linear model, we can check in whether linear model or linear direct regression. If you happens to select linear model, the model damping remains the same, 0.05 constant damping. Let's say if you go for linear direct integration is the other one. uh, things are a bit different, but so for time integration, new work is the one we use, studied in structural dynamics, and then this different ways. So these are like some of them if you want to go in depth. Other than that, we can just go for and include this additional modal damping, and for a constant damping of all modes, we are assuming this 0.05 of damping because it's a dynamic load. It is mu cu ku equal to f of t, so we need to define the cu. Okay, now we can also put it in a load combination, but for right now I'm just putting straightforward a load. So let me just assign a joint load of 10 kips minus 10 kips of sine load. Let me select the joint and then apply. Yes, so I have applied the load. So this is how you're supposed to add the dynamic load.